How are you doing? Happy Friday and welcome to live stream number 58. Today is September 15th, 2015. Like I said, it's Friday. We made it, man. That's a good feeling, isn't it? So let's see, where are we this week? So Monday, we did a live stream on the title blog inside of Fusion 360. Anybody missed it? You can see me struggling with AutoCAD. Tuesday, we looked at the guide rails. Remember that? We model up a cool little model. We use the guide rails to kind of like control the shape. Pretty cool little thing with the loft command. Wednesday, we talked about managing your data. So kind of like day-to-day best practices. How do you manage your data inside of Fusion 360? Yesterday was a bunch of shortcuts. If you're a brand new user, I don't demand that you got to use shortcuts, but as you're getting familiar with Fusion, I definitely think the shortcuts are something that you should get familiar with. Today is all about CAM. So if you're not interested in CAM, then it's Friday. Take the day off early. Go and drink a beer or something like that. For anybody else who's interested in CAM, that's what we're going to talk about today. I see we already got a bunch of people inside of the live stream. Really appreciate for you guys who is taking the time out of your busy day to join these live streams. And if you're watching the recording, what is the great thing about this? It goes up on YouTube. Thank you so much for taking time for that. Don't forget, down in the description area of the video is my email address, lars.christensen@autodesk.com. Any future topic, shoot them out, and I will do my best to get them in there. All right, I will jump into the live stream a little bit later, but let's jump in here and let's talk about some CAM inside of Fusion 360. So, I have this part here, and this is modeled up inside of Fusion, and it's not anything specific. You're probably going to see a video on the channel with this part a little bit more polished. It's something I'm working on for some campaigns. But the idea is to utilize both 3-axis and 2-axis, 2.5-axis CAM when you're programming your parts. And some of you guys are completely, let me go into the CAM environment here. I know some of you guys are, ninjas when it comes to the different toolpath in here. But, if you're fairly new to CAM, or if you're coming, like I did, you're coming from another CAM system and walk into Fusion, you get a little it's kind of a little hard, I think, to get your bearings when it comes to machining. And I don't think that's specific to Fusion. I think that's just in general. I remember back in the day when I started, I think it was probably like my Master CAM version 6 days. When I got to had to use some of these 3-axis toolpath, I thought it was pretty overwhelming. And I also, from time to time, get people who emailed me, that they're kind of like, when should I use one and when should I use another? So I thought that maybe if we just threw some toolpath on this part, kind of like maybe we'll clear a couple of things up. So, like I said, this part is just something that I kind of like modeled up. And I'm only going to do the top side we can see here. There is nothing on the back side. So put it in your vise and just start machining the top. Not really trying to complete a finished part. The setup have already been created. I just literally threw the origin right in the center and added some extra stock on it. Nothing specific. So when you start machining inside, generally in most CAM systems, normally you want to kind of like create a datum. So think about that you're throwing in this part, by the way, maybe it's important, is 3 by 6. Yeah, so 3 inches by 6 inches, just to give you kind of like a realization how big it is. So normally when you're throwing like a raw blank or something like that, the first thing you want to do is you want to chop off the top of the part, just to kind of like create a clean datum. So I'm going to go to the 2D operation. I'm going to just throw in a facing operation here, and that's all that's going to do, right? It's just clean off the top. I'm going to go ahead and select the tool, and for this case here, many of you, if you are working in bigger shops, probably have like face mills, like bigger diameter cutters for this kind of stuff. I am in this case here, I'm just going to go into the tutorial library, and I'm actually just going to grab a standard 1/2 inch end mill to face this one off with. And I'm just going to hit OK here for this at this point. And we get a toolpath up here to face this one off. Actually, so why would you go with a why would you go with a small end mill, not a big fly cutter? Well, generally you want to do it. You want to use the big fly cutter because you take less passes, right? So when I simulate over this part here, you can see how many passes it's going to take. One thing, just quickly, I like throw in there is that one of the nice things about if you're using this end mill and that's the same end mill you're using to finish this surface down here, using the same end mill for both, it makes it a little bit easier to get the height right because you don't have two different tools that have been touched off. You're using the same tool, and it's really just the machine Z movement that can do that. All right, so this is the first operation I'm going to put in there, just a facing operation. Now, the next thing is, are we going to select a 2D adaptive to rough some of this material, or are we going to select a 3D adaptive clearing? The difference between the two is that the 2D, you will pick the specific boundaries, but you get some flexibility with the 3D. So let me just select the 3D clearing here. And now for the ease of things, I'm going to leave it at the same end mill, and I'm not going to worry about feet and speeds. In the more polished video that's going to come up on the channel at some point when I get through all this, we'll have all that feet and speeds and stuff. Now, many times when I am working with CAM inside of Fusion 360, I actually just make sure I have a tool selected, and many times I don't go in and deal with a lot of the other settings first. I like to just hit OK and see what I get, because then I can start adjusting from that point on. Trying to go into all the different checkboxes and trying to tweak things in the beginning, many times you get lost. So just hitting OK and then looking at it and saying, oh, what do I need to do? So the first thing here is that this 3D adaptive actually does a pretty nice job machining this. If we go in here and we simulate this, and let's just change this to tail, turn the stock on, and hit the play button here. So first we have our facing operation, and then it's going to do the adaptive. It actually does a very good job kind of like cleaning up this part. It's a little hard to see with the colors. There you go. It does a pretty job cleaning up this thing. But a couple of things I see that I want to talk about. First of all, the depth. We probably are holding this in some kind of a vise. So I cannot have the end mill cutting all the way down to the end. It will cut into our jaws. So I will go in and address that the first. So I'm going to click on the operation. I right click and hit edit. And going over to the heights tab. And in the heights tab here, normally, I've talked about this before, start from the bottom and work your way up, because the bottom is normally the most important thing. And just so you know, you can actually grab these on the screen and you can move them up and down in that too. So I'm going to lift this up. Well, let's just say that I want to hold it in the vise by 1/2 inch. That should be pretty secure. And then actually I'm going to add another 100 thousandths to this, just to make sure that I don't touch the top of the jaw. Hit enter to that, and we will now see that the toolpath is only going to where the blue line is here, and we can now be secure about that. Let's talk a little bit about adaptive, just for 2 seconds here, because a couple of people have reached out to me about a little bit of a concern, because it's a little bit of a different toolpath than, well, if you're like an old schooler like me, where we used, back in the day, when you used to program CAM, you had to better tell that cutter exactly where it's going to go. And the thing about adaptive is that adaptive looks at the stock model you have defined, it looks at the model, and it's actually smart enough to create a constant chip load on the cutter for that stock versus that part. And it does a couple of things that is neat. One is, of course, it can go faster. That's all great, but unless you're doing production, that's not really the biggest selling point. The thing that I love the most about it is that it actually increases my tool wear, and that's money. So I like that. So let me just talk a little bit about the couple of things. So yes, feeds and speeds is definitely important when it comes to adaptive. But what I would recommend, if you're just starting out, take some conservative feeds and speeds in here and kind of like work with those. So in this case here, we're running like a surface speed of like 400 feet per minute, and that is definitely pretty conservative. Chip load per tooth, a little over 3,000. I mean, you could maybe go down a little bit. If you're starting out, I would probably, I mean, you got to make sure you get a decent chip. Maybe go 2,000s, but do something conservative when you start out. That's fine. The magic with adaptive clearing is when you go over to the passes tab, and over here there's two things. There is the step down, and then there is the optimal load. So one of the things is you can actually take a pretty deep cut with adaptive. So I'm going here 1 inch deep, but it's kind of like the depth, the length of the cutter, or the flute length on the cutter is 1 inch deep, and that's actually fine. So again, if you're old school, I used to do like 100,000 step downs and get a bunch of step downs. Forget about that. Go full depth with your cutter, but then the optimal load is what is important. And the optimal load is kind of how thick do you want the chip to be. And this is a number to play with depending on how rigid your machine and your setup is. So, I mean, you probably don't want to go any lower, I would think, than maybe, 30,000s or something like that, or 40,000s, because you need to create a chip. You can't just have the cutter kind of like bouncing off. But this is one of the numbers that you can, this number, so I mean, I would probably start out with, maybe just be conservative, start out with 75,000s, maybe 100,000s on here, and have some conservative feeds and speeds. Then between the feeds and speeds and this optimal load is where you can kind of like push things. So that's what I'm going to say about that. Also, we have some stock to leave here, so we can leave some stock because this is a roughing operation, and for some reason it's 20,000. I think is default. I don't know why I used to do 25, but that's just kind of like what I like to see in here. And let's hit OK. All right. And of course, at any point, we can go up here, we can right click, and we can simulate the operations that we put in here. So we did a facing operation, that's a 2D, and then we did a adaptive clearing, what we call a 3D operations. Now let me jump back again to a adaptive for the inside of this shape here. Now here I would actually probably select a 2D adaptive, because what the 2D adaptive does is it lets me actually select specific geometry for boundary conditions, so to keep within. So we're going to go in here and select the 2D adaptive clearing, and my half-inch end mill is not going to fit in here, so I'm going to go and select another end mill. So I'm going to select a quarter. So let's go in, move out a little bit, the tutorial folder. This, we all have this one here. Select a 1/4 inch end mill. Again, feeds and speeds in here. Again, be conservative, right? Maybe because it's a little bit smaller cutter, maybe I do 1,000 per tooth in here. Then the second tab is where I'm going to select my my boundary. So I'm going to select the edge of the bottom here. And then we can go over to the passes tab, and we can again see there's an optimal load. So maybe I go a little bit conservative with that one too. We could leave some stock to leave because we're going to have to finish these walls. Hit OK. Now, so one of the things you will see, the difference between the two adaptive is that this adaptive out here, it's smart enough to start on the outside and work its way in. But of course, when we do the center hole here, we got to work from the center and kind of like down to the bottom. And actually, I really, if you ever take a look at these type of toolpath here, This is the kind of toolpath you kind of like want to see when you are when you're simulating. I'll turn the stock off. These toolpath here, when we get down to the bottom here, I call them like fishtails. You can see how it's kind of like roughing this out. This is going to give you a beautiful kind of like the sound of this is good. Like the cutter is just like going in and cutting these here. But one other thing I want to talk about is you see how this entry here is helixing in, and that's the best way to. You really don't want to plunge down. Here's a neat thing that is inside of the 2D adaptive. If I right click and go in and edit it, if you go on the linking tab down here in the helix, you can actually add a ramp to the helix. So I'm going to put like 5 degrees in here. So now the helix is actually starting out and going in a taper as it's going down, really taking some of that center stress on the cutter there. So that's kind of like a good little thing there. So now we kind of have the part somewhat roughed out here with these couple of toolpath here. So let me just right click and do the simulate, and if we do the stock, you will see here is the first roughing, and then in the end here we've roughed out this pocket. But that actually makes me just take a look at the facing operation we do in the beginning, because when I'm looking at this facing operation, I realize that I actually only need to face this area off right here, right? Because that's where I want to create this datum. So one thing you can do, if you didn't know, you can actually drag operations in the tree here. So you can reorder things, and I can put that facing operation at the bottom. So first rough out all the material, then rough out the pocket, and then I can go in and create this facing operation. And if I go in and edit that, on that passes tab, I could see by default it does the whole stock, but I could just set this little boundary here, and now it's just going to do that little portion. That might be a little bit better kind of like layout for this, so we not wasting all that cutting time on a small area like this. Now the next thing is I really would like to establish the datum on this face here, on this area here, and there's actually a pretty neat toolpath under the 3D that actually don't do 3D. It's called horizontal toolpath, but what the horizontal toolpath does is it will detect all flat areas and kind of take care of that. So I'm going to select the horizontal toolpath. I'm going to switch to our smaller cutter here, the smaller 1/4 inch flat end mill. Fit a little bit better on this area. And like I said before, don't be afraid to just hit OK and kind of see what you get. So you can see that the toolpath finds all the flat spots in here, including up on the top. What makes you think we could actually maybe have used that as a facing operation, but whatever. So let's go in and kind of like, I only really want to touch the top up here. So right click, go in and hit edit. And again, that was under the 3D toolpath. So we're kind of like switching back and forth. 3D, 2D, 2D, 3D. Let's go into the geometry tab, and we can actually set boundaries in here. So it comes normally with none. That means it just looks at the entire model. You can kind of do in bounding box or silhouette. What is really, the silhouette is really like if you shine the light from the top down on the part, and anything the light kind of like hits. But then you can also do selection. So I'm going to hit selection here, and I am going to select this edge and this edge. What really just tells the software stay within those two boundaries. Now you get some different options in here in regards to tool containment. Now I really don't want the tool to machine anything. Like you see there's an additional offset out here. I really don't want it to go down and touch these areas down here, so let it go besides the area. So I'm just going to go here and set it to the center of the boundary. But this additional offset that you see in here can actually be kind of handy. If I just say put it to 0 and hit OK, you will see that I am machining on all the areas I would like to touch. But you will see that it kind of like broken up the toolpath, and it enters on the center, on the stock itself. It kind of like comes right down. And if you have done any machining, you're thinking, well, can you just start from the outside so you don't plunge down in material and just come in for the side? And that's where, if I go in and edit it again, that you could use that additional offset. So if I put 100,000s in there and hit OK, I am telling the software that it can move beyond that adds. And now you will actually see that if we simulate this, that now you will see that the cutter actually will come down and it will start from the outside. Now, if you're looking right now, you can actually see there's some red marks down here, and I actually get a red tool holder too in a position. So let me move over here. See how that was red? Let's pause it. Hold down the button. I can see how it turns red. That is just because I selected this toolpath by itself to simulate, so it doesn't see the other ones. If I go up and I simulate on the setup, so I'm actually simulating all of them, and we then move to the horizontal toolpath by clicking here, left clicking, and we hit play, you will see that now we don't have any red lines and no red tool holders, because it knows that that material have already been removed in the simulation. That's just one of the great things to keep an eye out for. If you do see any red lines, you need to attack that. So this is pretty good. So we're kind of like mixing in the 2D and the 3D toolpath in there. Now, the next thing I'm going to do is I'm going to actually finish these pockets in here, here, and here. And for that, I'm going to use the pocketing toolpath. So I'm going to select that. I'm going to leave it at the same end mill. I know that you probably want to finish and rough with different tooling, but just for the ease of things and just to create a quick part, we can definitely do this. Now, here's something neat about Fusion 360. This is a pocketing operation, but the software is smart enough to know that if I select this edge right here, that this is an open pocket. So if I hit OK, it's smart enough to know that it should start on the outside and machine in. So that's kind of neat. So let me just right click and edit it again. And I'm going to do, I'm going to go to the selection. I am also going to select this edge over here and actually also our closed pockets. That is perfectly fine here. A couple of points to point out on this toolpath, I think is important, is you can control your maximum step over to whatever you want. So this is a 1/4 inch end mill, so 0.25. I would probably do, that would probably be my default. Be aware that there's stock to leave on this, so you can turn that off because this is actually going to be a finishing operation. But because it's a finishing operation, you can also add a finish pass on there. So I'm going to do that. I'm going to say that I want a finish pass, just one of them, and it's going to leave 25,000 to clean that up. So I'm going to hit OK, and let's take a look at that. So what the finishing toolpath, where that happens, so let's just do a quick simulation of it. So it's going to do the hole first, what is fine. Oh, and actually on the hole, I actually don't want it to ramp in. Like helix in, because we already roughed out all that other material. So let me just take care of that. Right click, edit, and everything that has to do with lead in, lead out is on the last linking tab over here. And by default, it does helix, what is fine because normally you have maybe some material there. I'm just going to change it to the plunge because there's no problem for it just to come straight down. It doesn't have to helix in. All right, so what I wanted to show you when we simulate this, and of course, again, I get a bunch of red bars just because I'm simulating here without the previous operations in the truck count. What I want to show you is that it does that step over, but then it also going to do that finishing toolpath right here. So maybe actually easier to see if I just show all the toolpath. Can you see that there's that second toolpath right there? The second blue line is that 25,000 step over. So it's just going to finish the wall. What I think is most cases is fine, right? Just coming in and stepping in, and then in the end, I just want you put it right there. So just step in here. This is fine. Machining, the step over, and then in the end, just coming in here and removing that material. Actually, I just realized that the step over is not right. See, this is why you always gotta simulate. Let's take a look at this. If you simulate, and let's go to the last operation, turn the stock on. So we're at this point, and it's gonna run the whole. What is fine? I think it's gonna move over here. Oh yeah, that's us do it. Okay, sorry. I thought that my step over was too big. So here you can see that it cleans it up, and then it's gonna come in and just take that last 25 thousandths right there. Okay. But actually, when we're doing that, we should actually probably also machine the outside finish. You can see how we get a little bit of a step over there. I should probably actually have done that before. Maybe I did the pocketing just for a better blend. So let's do that's a contour toolpath. So let's go up and select the contour toolpath. I'm going to go back to my bigger end mill. Okay. And for geometry, I'm going to select that bottom edge. I just want to machine around the outside to get that into size. And I'm going to do what I did also with the adaptive, was that I just going to raise it up that 600 thousandths in there. So it's above. The cutter just goes up to here. And then actually I want to show you a little trick that I used to do. It's like these small things in life, I think. If we, and I wanted that before the pocketing, so I'm just going to move it up there. So now it's before the pocketing. So I don't know if you ever run into this. Maybe you guys, a bunch of you guys already do this. But when we get to this contour toolpath, just to clean off the outside, you see how it's starting right here on the center? And then it's going to end on the center of that block again there. It always leaves a little mark right there, right? The cutter comes in, it kind of like, it just sucks the cutter right there. What I always used to do was, first of all, see how I actually modeled in the chamfer? So that means that I don't have to worry about chamfering this one with a file afterwards. It's just like a 20 thousandths chamfer in here. So I always did that. Break the corners so you don't have to worry about that. But then when you go in to do your lead in, lead out, you can actually set an entry position. And if you just select that edge, now the toolpath starts right on that edge of that, right on that cut, right where that edge is right there. And you're going to end up not having that mark where it sucks right in there. It's the small things in life. Okay, so we are almost done with this thing. We've done we've done the roughing. We roughed out the center pocket. We did a little bit of facing. We corrected that. We did some horizontal 3D toolpath to clean up all this beautifully. We did a contour to go around it. We did the pockets here. And now I want to attack this tapered wall here. So for that, I'm going to use, of course, a 3D toolpath. And for that, I actually did a video where I'm talking about what some of my favorite toolpaths are in here. You can search it on my channel. So I talked about the contour, the parallel, and the scallop toolpath. For this here, I would use the contour toolpath. I'm going to select the ball end mill because we always use ball end mills when we are doing surface machining. Use ball end mills for that. You can't use flat end mills, so not with a good result. So I'm going to select just another 1/4 inch ball end mill here. Hit OK. And for the boundaries, I'm going to do, you could do silhouette, but we'll do again the entire part here. But I really want to contain just in doing this cone shape. So I'm going to go in and hit selection. Hit this top up here. Hit this top over here. And if you remember, what the adaptive did was it actually roughed. I should do that. The adaptive did a nice job roughing this out. When we go in here, turn the stock on, that's fine. See how the adaptive, the first adaptive, kind of like made a staircase out of this area here. That's great, but what I probably want to do is I want to do kind of like a rough and a finish for this area here. So this is going to be the first one's going to be my rough. So I'm going to select those two, go back to where I was, select these two boundary areas here. For this one here, I'm actually just going to leave right now the tool on center, where everything is in here. Let's go over to the passes tab and talk a little bit about that. So I probably want to leave a little bit of material for my second operation. So maybe like, I don't know, 10,000s or something like that to clean up. Step over, it really depends on what kind of finish you want. I'm going to talk about finish in a second. If you just want to rough this one in, I might just do like a 30,000 step over just to kind of like get things somewhat roughed down and be kind of like smooth. So if we go in and we look at the simulation, and this simulation is actually going to be pretty dang close to what you're gonna end up. So you will see that there's gonna be some bumps on this surface here, but at least we're getting rid of these staircases and kind of like gets it smoothed down pretty well. Now, here's a little trick for you when you start talking about surface machining. Well, I don't know if it's a trick, but here's a little reality. Anytime you can right click on an operation and you can say machining time, and it of course depends on your feet and speeds, and that will give you an idea about how fast an operation is. Now let's just go in and look at these feet and speeds for a second. So you can see this one is going really, really fast, 20,000 RPMs, and it has a feet per tooth of like almost 5,000. That's pretty aggressive, I would say. Let's just go and say that we want to be a little bit more conservative. We're going to go down to an 8,000 RPM, and I'm going to change my feet per tooth to, let's just maybe do 1,000, right? With this here and hit OK. This is definitely, if you're cutting softer materials, this should be, even like lighter steels, this should be decent. Let's hit OK. And let's go in and look at this. Right click and go in and say machining time. And you can see here we're about 10 minutes. And that's actually, that's not too bad to rough something like that out, I think. So I'm just going to leave that there. Now, like I said, I would probably do a rough and a finish. So instead of going up and picking the whole thing again, you can actually right click and you can do create derived operation. And I'm pretty much just copying the same everything into that contour again. So it's still using the same ball and mill. It's using the same feeds and speeds. And at this point, all I got to do is going over to the passes tab and I got to change. We don't want any more stock to leave. And then we probably want a nicer finish. 30,000 is probably pretty rough on here. So how far can you go? What should you run this with? And I always tell the story about, remember being a mold maker and programming things like this. And, many times what I would do is I would come up with a number. So, for example, you decided, okay, let me just try at, let's say, 10,000. And because there's not really any magic with this. And you would go out and you would run that. And what I many times would do was I would start machining it and just machine for a couple of minutes and then stop the machine and look at the surface finish, because that's really what matters at this point, right? How nice does the surface look? And then the boss would come over and he's like, oh, you need to make it a lot finer than that. It's got to be a lot nicer. And if we go in and we look at this time, so at 10,000s, it takes 22 minutes. Well, if I got to make it a lot nicer, so let's go in here and let's change this from 10,000s to 1,000s. Now, for some of you guys, European guys, I don't expect you to know what 1,000s is. 1,000s is about a thickness of a human hair. 3 thousandths is the thickness of a human hair. So this is like a human hair split in about 3 pieces. We go in and we process this, and you will see now you're going to get a nice, lot smoother toolpath right here, right? Very tight toolpath. When you go in and you look at the machining time, you have gone from 22 minutes to, almost over 3.5 hours. Now, if you have 3.5 hours, like running it after when the end of the day and you're walking home anyways, that's perfectly fine. But if the customer's waiting, so that's really my kind of trick to, how fine do you need it to be? That really depends on, how much time you have. Time equals money, right? So 5 thousandths here, 5 thousandths step over. And let's go and look at the machining time. And that's about 45 minutes with those feeds and speeds. That was fairly conservative. So right now, if you right click on the top and we look at the machining time, we're about 1 hour and 15 minutes, what is not, insane. Especially if it's like a mild steel and we're being pretty conservative. The last tool I want to show you in here that you need to know about, that's actually a 2D tool, is the 2D Chamfer tool. It's not brand new, but it's one of the newer toolpaths. Now this is pretty neat. So I'm going to select the Chamfer toolpath, and I am going to go up and select a chamfer cutter, of course, something that has like 45 degrees on it. So I'm just going to take this chamfer mill here, hit OK. And for the selection for this, I'm going to select the outside. I'm going to select the up top pocket here. And I'm actually also going to select these 2 edges here, because this 2D chamfer toolpath does something pretty cool. It actually knows where the material is. So if I hit OK, like normally if you've ever chamfered anything and you're looking at this edge right here, you'd be like, oh man, I don't want to do that, because if I do that, then I'm going to smack in with my cutter right here. And if you've ever done some regular chamfering in your machine, what I actually am a favor of chamfer right in the machine instead of standing there with files. But if you've ever done that and you made this mistake, that's just horrible. But this cool thing about the 2D chamfer tool is that it knows how big the part is, and it knows the tool size, so it actually cuts it short. So if we go in here and we go in and we simulate this, and I'm running a little bit over my half an hour here. I hope that's okay. If we go in and look at the chamfer operation, let the software catch up here in the update. Just right now it's working on our 5 thousandths. It's got to solve all that 5 thousandths there. Here we go. So it's going to chamfer around. This is actually a pretty big chamfer. Here is, and you will see also that it stops right there because it sees this area and is making a pretty big chamfer. So that's why it's avoiding that, because it knows it cannot touch that. And that's the same thing it's going to do when it's going to come down here to the end of this, is that it's smart enough to know, and I'll owe somebody on the development team a beer for this. It's smart enough to know that cutter diameter and don't want to hit with it, so it cuts it short, and the chamfer starts only where it can go. See that? So it comes right down there, so it never hits that wall. What is absolutely awesome with that toolpath. The last thing, just so you can see that we can fix this little thing up here. I don't need a chamfer that is that big. If we go in and we edit that tool, go to the passes tab, you can choose the chamfer width here. I mean, 40,000 chamfer is pretty dang big. If we change it to 10,000, you will now see that it made it straight here, and it actually probably also gotten a little bit closer to the edge here. So I hope that this was useful. I got a couple of emails from people who wanted to see something from start till finish when it came to CAM, and I really like the idea about mixing between those 2D and 3D different toolpaths. I hope that this gives you kind of like a little bit of a more of a feel for how you can do that. Like I said, this will be probably a little bit more polished video on the channel, and at that point I will also give you access to the file with the toolpath and feeds and speeds, and then you can literally go out and you can test it on your own part, on your own machine, and kind of like get a feel for how this whole thing would be machining. So I really, really hope that this was useful, even though that I'm running like 40 minutes on a Friday. I like to keep them between 15 to 30, but I thought that this was an interesting part. As always, really appreciate that you are taking your time out of your busy day to join the live streams, and if you're watching the recording, thank you for doing that. It's Friday. It's about almost beer time here, and I hope the same is for you. I'm going to do what I normally do. I am going to end the broadcast, so if you're watching the recording, thank you so much. If you like this and want more of this, let me know. Hit the thumbs up there. If you don't, if this is, waste of your time, hit the thumbs down. That's perfectly fine too. My email address is down in the description area. Shoot me an email. I'm going to end the broadcast. For all you guys who are inside of the live stream, I'm going to come in and say hi to all you guys. Really appreciate that you're taking the time out of your busy day. Take care, guys. Have an awesome weekend, and I'll see you Monday.